Okay, so on this question, we're supposed to simplify, and we've got this two square roots. And so what can we do? Well, basically, you can cancel things since they're both in square roots. So 4 into 108, I'm going to use my, well, I think I can do 4, the 27. Yeah, 20, it goes in 27 times. And then, but here's what we want to be clear about. Make the bar here and the square root on the top. The 27, the 4 went into 108 27 times. The 27 is still inside of a square root because it came from stuff that's inside of a square root. And then the into the 4 cancels into the 6, leaving n squared down below. Still in a root. And then finally, the k squared goes into k to the 10th, leaving k to the 8th on the top, also still in the square root. Okay, we good so far. Now, do you see what I've done? I just simply canceled stuff, right? I just went 4 into 108 27 times. And then I subtracted powers. We had into the 6th on the bottom, into the 4th on the top, so that left n squared on the bottom. We had k to the 10th on the top, k squared on the bottom, left k to the 8th on the top. Okay, so now what do we do from here to simplify this? Well, now we break stuff down. So if you do the 27 over on the side, it's 3 times 9, and 9 is 3 times 3. So that becomes, let's see. Oops. Square root of 3 times 3 times 3, that's 27. And then we have our k to the 8. Hey, let me make this question more interesting. Let's pretend this said k to the 11th. Okay, I just want to make it more interesting. Then this would be k to the 9th right now, right? What would we do? What do we always do with odd powers? Odd powers, we always write even and one more. Right, that's how we write an odd power. We say, well, an odd power is even, and then there's one more. So it's going to be k to the 8th, k. Tracking with me? That's how we would write k to the 9th, like that. K to the 9th is k to the 8th and one more k. That's still 9. You see, 8 and 1 is still 9. We just make it even so that we can divide the power in half. And then on the bottom, we have the square root of n squared. Okay, so now what do we have from here? Well, it's a 2-for-1 deal. So 2 3s inside sends 1 3 outside, and they're gone. And 8 k's inside send k to the 4th outside. Excuse me. And then they're gone. Okay, and so what are we left with now? And so again, and then we're just left with 3 and k. On the inside, on the bottom, n squared sends out a regular n, and it's gone. And the root vanishes because nothing is left inside. So it's plain n. You see what happened there? So in that last step, the 3 3s, so 2 3s in, sent 1 out, right? Because roots are a 2-for-1 deal. 2 3s in, sent 1 3 out, and 8 k's in, sent 4 k's out. So 3k to the 4th out. What do we left inside? 3 and k. The bottom, n squared sent 1 in out, and the root's gone because there's nothing left inside the root. So there's our final answer. We got it. So from the beginning, we canceled, subtracted powers, and then we broke down the 27, did the 2-for-1 ship out, and the even powers 2-for-1. For the odd power, k to the 9th, we have to make it an even and one more. Make it k to the 8th and one more so we can cut the even power in half, because that way you can do the 2-for-1, right? You have to have an even amount to take advantage of a 2-for-1 sale, right? If you're at Target, things are on sale 2-for-1. You got to have an even amount, 2-for-1. So that's why we take the odd power, we break it into even and one more. So there we go.